Hello, Shamini sir. Good evening, sir. Sir, please start your webinar.
Okay, ma'am. Starting, ma'am.
Okay. Please share your screen.
Ma'am, is my screen visible?
No, sir. Your screen is not visible.
Ma'am, now?
No, no, sir.
1 second, ma'am. Ma'am, now it is visible.
No.
Ma'am, it is showing that my screen is being shared, I think.
Yes, yes. Now it's visible.
Yes, ma'am. So, shall I start, ma'am?
Yes, sure. Sure, sure.
Okay, ma'am. So, good evening, everyone present. My name is Somindra Sen. So, today I'll be presenting on the topic of vehicle theft detection using IoT. So, before starting, I would like to introduce myself. I belong from Kolkata, West Bengal. I study in Techno Main Salt Lake. I am currently a third year undergraduate student in Electronics and Communication Engineering Department. So my field of interest is IoT, and I am currently working in web development sector. So that's all about myself. So now we shall 1 second, ma'am. So we shall discuss the agenda of our discussion today. So basically, we will be starting with the abstract, that is the everything about our project which we have developed as a personal project. Then we will dive into the existing system which already exists in the market, and then we will discuss the problem statement. Then we will propose our system and the device which we have developed, then a bit of survey that we have done, and then we will dive right into the components of the system and the basic technicalities related to our project, like data flow of Bluetooth module, vibration sensors, and GPS. Then we will discuss the software requirements and the hardware requirements. So let's start the presentation now. So we know that the prime concern nowadays is the security of our parked vehicles, be it anywhere in India or outside India. So a smart IoT device for two-wheeler system as well as for four-wheelers that we have developed, it not only can track the vehicle but also can alert the user even when the slightest displacement of the vehicle is noticed. That device actually makes use of a GPS system and also electronic mail, that is email system, for alerting and notifying the users. The system can actually be operated in two modes, that is the active mode and the parking mode. In the active mode, basically the system is off, which means the system is not connected to the user smartphone. In this period, the user is around his vehicle, or he is driving his vehicle. And in the parking mode, that is the second mode, the system is connected to our cloud server, and also the cloud server is connected to a cloud based database, and through a low wide area network. And where the system and this is when the system detects the movement of the vehicle from the vibration sensors attached with the vehicle, and also alerts the user if any kind of ill activities is noticed, or any kind of movement of the vehicle is noticed. So that's pretty much about our project that we are preparing right now. In the future, it will become a very small sized and a low price device, since now our project is in the prototyping stage. So it is quite expensive also, and it has to be managed a lot. In the later course of action, we are planning to develop it so that we can integrate everything in a single chip, and whenever the production starts, it will be a very small device. So moving on, the existing system, we will discuss that what kind of technologies already exist in the market, and basically which can be our competitors. So there are basically various anti-theft devices which have been developed lately. However, we know that the results which they are giving is not very satisfactory. In domestic and overseas vehicle theft products, there are basically two types of systems. That is the vehicle alarm system, and the second type is a GPS based vehicle tracking system. So discussing about the GPS alarm system, which all of you must be knowing that it is the basic kind of system that is installed in every vehicle nowadays, that whenever we pull the door or something like that, so there is a siren that boots up, and it plays, so that it alerts the other public. So and the second kind of system is that typical GPS based tracking system, that is they are in some high end vehicles. So in this case, it pretty much matches with the product that we are developing. So it also uses GPS and GSM technologies, and locates the vehicle and also alerts the users, and it basically actually can be our competitor. So if we discuss about the advantages which the existing system provides, it has an anti-theft alarm and a vehicle tracking system. The tracking of the device using GPS tracker is also available, and most importantly, it saves time in finding the vehicle if it is stolen at all. And but there are certain disadvantages also. So first disadvantage is that it consumes more energy, since the GPS tracker has to be on 24/7, and it does in terms of notifying the users about the stolen vehicle or locating the vehicle, it is not very satisfactory, and the sound is also a bit annoying. So now we would like to discuss the problem statement. That is, as per our studies, we have noticed that around 1 lakh cases of vehicle theft is reported each year just from India, and the number is continually increasing. So in these situations, the vehicle that has been stolen cannot be recovered very early, and in those cases, they are either sold off to a distant location, or they are burned off or resold, and it becomes very difficult for to retrieve those vehicles. So keeping these things in mind, the main problem of the existing system that already exists in the market, that the GPS tracker tracks and monitors the vehicle 24/7, but it consumes a lot of energy, and it is also not very what to say, it does not takes into account the processing of data, and it does not give the user the opportunity to have a real time tracking system of his vehicle. So moving on, we have the proposed system which we are proposing, that our system will actually have a on off switch, which the user can control from his own device. Now it is an Android device, but it will later be switched on to both web based and iOS applications as well. So when the user turns off the switch, the our IoT device goes into the active mode. As I have discussed previously, what is the active mode? Now, when the user disconnects from the device, it goes into the parking mode, and the device is connected to the cloud server 24/7. But it uses a low power wide range network. So in that case, it saves the power pretty much, and also saves our battery of the vehicle. And when the device is in parking mode, the movement of the vehicle is sensed using the vibration sensor, and the owner is notified along with the GPS coordinates of the vehicle. And at the same time, those coordinates and all the informations are stored into the database, which will be uploading into the cloud servers. Now, the main advantage of our system is it is small size and light in weight. It is very sophisticated in terms of the security systems, and it consumes very less energy. And it also notifies the users immediately, and it also helps in tracking the vehicle using maps, and it also helps the respected authorities to recover. It also helps them as well. So this is a bit of the literary survey that we had performed when we were developing this project. So we can skip ahead with these things. Now now we have the flowchart or the basic diagram of our components that we have implemented. So as you can see that in the heart of everything there is a node MCU, that is the microcontroller board which controls all the parts which have been employed in our device, that is our project. It consists of a vibration sensor, battery, GSM module, and GPS module. And using the GSM module, we actually connect to the internet, and the user can access the entire system using the internet from his mobile application. Now moving on, this is the data flow diagram. As we call it the active mode, we refer to as a level 0 in terms of computing. So there is the system, and when it is in the active mode, the system is directly connected to the um, it is not connected to the smartphone, sorry. So we can see that there is a dotted arrow in the parking section. So it is connected to the parking, and in this time the system is actually working on its own. It is directly connected with the servers, and it will automatically uh, message the message or send an email to the user whenever any illicit activities is noticed. And next we have this parking mode. In this data flow diagram we can see that uh, the system is connected to the smartphone, and it will actually notify the users in the same way as discussed previously. And this is the flow diagram of the GSM module. So all these are actually the technical parts which I think is worth mentioning here. So the system actually sends coordinates and the registered number data. GSM module receives it, and it processes something and sends the coordinates to the registered mobile number of the user. Now this is the basically the entire diagram of our system. So anyone who is quite adversant with the web development technologies will know this, that this is basically same as the client server architecture which we follow in the websites. So it basically is same, only there is a system in between which makes all the calls using IoT devices and sensors. And then we have the basically these are all the electronics components that has been used, their numbers and all. We can skip these things. Now the most important thing is that the software which are required to develop this project. So basically we will need the knowledge of some development program. In this case we have used C++ for programming our node MCU, and we have used Java and XML for making our Android application, and we have used Blink to design the circuits and a node MCU software also. And then talking about the hardware requirements, we have already mentioned, still I'm going through. There are GSM module, vibration sensor, node MCU, GPS tracker, and a battery. All these things are actually available in the market and can be bought anytime, but it becomes a little bit heavy on the budget side. So as I've already mentioned, as we can progress in this project, we will be able to reduce the cost by integrating all these things in a single chip. So now these are the functionalities of each component. You can have a look through these things. These are all vibration sensors and other modules, etc. So this is the lithium ion battery and the GPS tracker. All these things are available in the market actually. So now to conclude, I would like to say that it took a very much effort in our side to the may arrange these all things and put them together, program the components and put it them into the web. So we are actually we have prototyped and also shown this device in various hackathons that we have performed. And this project actually achieved all the targets that we had made, but still there are lots of scope of improvement. So nevertheless we are progressing with this project. So that's all for this presentation. So I would like to conclude the session, and thank you all.